Welcome back, students. In the last class we have discussed about embedded firmware development languages. In that we have finished assembly language based development. Now we will go to high level language based development and later on combination of assembly language and high level language, right? So coming to high level language based development, okay. So generally we consider the C language as the high level language. Here we are considering the development that is C. The most common used high level language for embedded firmware application development is C. Okay. So various steps involved in high level language based on embedded firmware development is same as that of the assembly language based development. So most of the steps, okay, in the previous class we have gone through the steps how the assembly level language is converted or transformed to machine level language. So the steps are mostly in common, except that in place of assembler we will use a cross compiler here. Next, except the conversion of the source file written in the high level language to object file is done by the cross compiler as I mentioned. Whereas in assembly language based development it is carried out by an assembler. So you see the conversion steps, that is various steps involved in conversion of a program written in high level language to corresponding binary language is illustrated below. So if we see the difference, okay, in the last class we have seen the same figure with respect to assembly level language. In place of here, there we have user assembler, okay, in order to convert the respective source file to machine level language. For assembly level language based development, we have used an assembler in this place, in this block. Now we are using a cross compiler. Here also is a cross compiler, okay, and the object file is same, object file. The linker and locator are common, and linker and locator converts the different object files into a single absolute object file. Okay, later on converted to the respective hexadecimal file. So this is the process. Okay, what is the differences with respect to the conversion? Here we are using the cross compiler for converting the respective source file or source code into machine level language. We are using a cross compiler here. In assembly level language based development we are using assembler, right? So these are the steps involved to convert it to machine level language code. So what is a compiler? What is a cross compiler? Okay, actually we have a topic in Unit 3. The last topic is about compiler and cross compiler. Anyway, here we have came across the word compiler, so we are just mentioning it. So compiler translates program for same hardware. Remember, same hardware or platform or machine on its running. Okay, it converts the code for the same hardware. Next, cross compiler translates program for different hardware or platform or machine other than the platform which it is running. See, for example, take hardware. For respect to hardware, there is 8051. There is the hardware. So we are writing the code in one specific software tool. Okay. So if it is only if the respect to the after compilation, the respective code will run only in 8051. Only 8051 is said to be a compiler. The respective code runs in different platforms. Okay. Means the compilation cross compiler means, okay, the respective code will run in different platforms, different hardware, different machines. Okay, the respect to cross compiler. What is it? Cross compiler does the cross compiler translates program for different hardware. Okay, not only only 8051 for Atmega, so different microcontrollers, different processors. It will compile the cross compiler will compile only for one specific platform, one specific machine, one specific hardware. That's the main difference. Okay. For if it is translating the program, okay, for only one specific platform or hardware or machine, it is said to be a compiler. If the translating of program is for different platforms, different hardware, different machine, it is a cross compiler. This is a major difference with respect to compiler and cross compiler. So high level language, what we have used? Cross compiler. So you can translate the program to run in different platforms, different machines, different hardware. Okay, if it is only for one specific hardware, that is not a cross compiler, then we have to write it as a compiler. So here it is a cross compiler. Next one, so what are the advantages of high level language based development? So what are the advantages? We have considered the advantages of low level language based development. Here also, so what are the first one is reduced development time. Okay, in high level language based development, the number of steps involved are very less. Okay, number of steps involved are very less. So the development time will be also less because already the ready-made functions are available. Directly use this function right to respective program. So development time is very less. Second one, developer independency. Developer independency. Okay, so it is not dependent on one respective hardware. Assembly level language means we have to depend on the respective hardware. According to the respective hardware instruction set, we have to write the code. Here it is independent. Okay, so high level language means we can choose any high level language. You can choose any hardware. Right, so developer independency. Third one, portability. Okay, as a low level, the assembly level language based development is a non-portable. Is not portable. We have to stick to one specific hardware. Okay, here we will not stick to one specific hardware. You can change the code, you can change the hardware, you can write the code, make it cross-compile to run on different platforms. So it's very portable. Next one, what are the limitations of high-level language-based development? Some cross-compilers, not all, some cross-compilers available for high-level languages may not be so efficient in generating optimized target processor specific instructions. Okay, not all. Some cross compilers are available in the respective software tool. Okay, the software tool provides the compiler or the cross compiler. So some are not that much efficient and may not provide optimization with respect to the processor. So such compilers may be messy and no optimization in terms of performance as well as code size. Okay, so these are some limitations with only some specific software tools, okay, or some specific cross compilers. Next one is we have completed language with respect to embedded firmware development approaches. First one is assembly level language based development or assembly language based development. Second one is high level language based development. Okay, we have completed the high level language based development. Next, third one is combination, that is mixing assembly and high level language. Okay, so high level language and assembly languages are usually mixed in three ways. So how you can mix or you can combine high level and low level language in three ways. Okay, in three ways. First one is mixing assembly level language or assembly language with high level language. Second one, mixing high level language with assembly. Okay, so mixing assembly language with high level language. So the code is in assembly language, we are mixing the high level language. So mixing high level language with assembly language, similar. Okay, next third one is inline assembly. I will go through this. First one, second one, third one. First one is the code is in high level language, we are mixing or we are including some assembly level language. Second one is the code is in assembly level language, we are including some high level language. Third one is inline assembly. We will go through this inline assembly programming. That is first one, mixing assembly with high level language. In some applications it is very necessary. Okay, for example, there will be some process specific instructions developed by the processor itself. Okay, for example, 8051 has its own instruction set. For some applications, by writing a simple one-line code, one-line assembly level language code, you can directly call the respective operation. Okay. For some applications or for some operations to be done, in order to write from some 10 lines of assembly level language code, okay, we can simply write a 4-line high level language code. So depending upon the operation and the controlling technique, okay, so we will choose where the assembly level language is required, where the high level language is required. So assembly routines are mixed with C in situations where the entire program is written in C. Entire program is written in C, and the cross compiler do not have cross compiler. See here, the situation is the cross compiler in use do not have built-in support for implementing certain features like interrupt service routine functions. Okay, this is one of the reason. Okay, this is one of the reason where we are mixing some assembly level language with respect to high level language. Next, mixing high level language with assembly. Code is in assembly, we are including some high level language. So mixing the code written in high level language like C and assembly language is useful in the following scenario. What are the scenarios? Okay. So what are the scenario 1, scenario 2, scenario 3? There are three conditions where we are going to mix some high level language with some assembly level language. So what are those situations or what are the scenarios? Scenario 1. The source code is already available in the assembly language, and the routine written in a high level language like C needs to be included to the existing code. Okay, once again I am repeating, the source code already available in assembly level language. The source code is already available in assembly level language, and a routine is nothing but a program which goes for some respective address, run some task and come back to the same position. And a routine written in a high level language like C needs to be included in the existing code. So in order to where here we have already discussed it. Okay, the cross compiler has some issues by implementing certain features like interrupt service routines. Okay, right? Here also the same issue. Okay, in order to run the routine, we are just including some assembly level language code. Okay. Next one, second condition, the entire source code is planned in assembly code. So here, and entire code is in assembly code. For various reasons like optimized code, optimal performance, efficient code memory utilization, proven expertise. See, these are all the advantages of assembly level language. Optimization of code, optimal performance, efficient code memory utilization, and proven expertise in handling the assembly, etc. These are all the nothing but advantages in assembly language code in handling. But some portions of the code may be very difficult and tedious to code in assembly. For example, 16-bit multiplication and division in 8051. Here the thing is the code all is in the assembly level format. But some operations like 16-bit multiplication and division are very difficult to run, may take time, and these advantages may get affected. So in such conditions, we will include some high level language code in the respective assembly level language code. Simple. Next, third one, to include built-in library functions written in C language provided by the cross compiler. For example, built-in graphic library functions and string operations supported by C. Okay, so in a high level language supports some string operations, graphic operations. Okay, so as an assembly level language may not support those. Okay, so we are involving such type of graphical included operations such as graphics library function in the respective assembly level language code. So these are the scenarios where all the code is in the assembly level language, but due to some effects caused for code memory, optimization, performance. So we are including some high level language. Okay. Last one is inline assembly. So inline assembly is another technique for inserting target. Listen carefully. For inserting target processor or controller specific, process specific, controller specific assembly instructions okay, process specific, control specific, assembly instructions at any location of the source code, written in high level language. So this avoids the delay in calling an assembly routine, okay, from a C code. Assembly routine from a C code. See here simple is we have some library functions, we have already the respective software included. Okay. So in order to call some specific processor functions or some specific controller functions, those instructions must be included in the libraries of the high level language. So it is easy to call. And this avoids the delay. Routine means after getting some interrupt, we used to go some one respective address, vector address. There we have to run the respective program, or some small execution, an interrupt or a signal. Then we have to come back, we have to resume. Okay, and there we have to follow the respective assembly level language code libraries or respective high level language code libraries. So we have of that inline assembly. So while designing the software only, if we include the respective assembly level language libraries or high level language libraries which are specific, whatever the needed with respect to one processor or controller, then it is easy to call. The delay may be reduced for the compilation or the cross compilation. That is what mean by assembly language. Okay, sorry, inline assembly. So in the last class we have already discussed about the last class I already discussed about embedded firmware development languages. Okay, in embedded firmware development languages, we have discussed about assembly level language, that is low level language, high level language, combination of both assembly and high level language. So in this class we have discussed about high level language. Okay, in this class we have discussed about high level language. Next we have discussed about the steps to be followed and to convert the high level language to the respective machine level code. Next, what is meant by compiler and cross compiler. Next, about the advantages of high level language, their limitations. Okay. Next, in the combination of both assembly and high level language, we have three ways. One is the code will be in high level language. Okay, the code will be in high level language, and we are including some assembly level language. And second one is the code will be in assembly language, and we are including some high level language. And third one is behalf of calling these three things. Okay, behalf of calling the program will be in high level language. Okay, we are including some assembly level language. The program will be in assembly level language. We are including some high level language code. Behalf of doing there, what we are doing, we are calling some routines, which may cause some delay. Okay, not to read out that respective library functions. Okay, there is some delay. So what here we are doing, by designing the software itself, we are including the respective library functions, respective operations in the code itself, in the compiler itself. Then the delay is reduced. Okay, but here what we are including, we are inserting target processor controller specific assembly instructions, whatever needed, whatever the instructions we are needed, we are including those instructions only. Okay, these about the topic. Okay, these about the topic. This is about the topic, that is embedded firmware development languages. Okay, this topic also finished. Embedded firmware design approaches, first topic finished. By today we have finished the embedded firmware development languages. In the next class we will deal about ISR concept. Okay, ISR concept. ISR means interrupt service routine concept. Okay, thank you.